In this lesson, we're going to talk about arrays. An array is just a list of numbers, typically. And in this source file, I've defined two functions, a and b. You can tell their functions by this brackets here that says it has 5 elements. Array A, I've initialized. I've given it 5 values. Notice the use of the curly braces to put the values in. Array B, excuse me, has not been initialized. It's left blank. You cannot print out all the values of an array at once. There's no function in printf for printing an array. Instead, you have to print them term by term. Here, I've just added a line to print out the 4th element of A, A4. Let's print and see what we get with this. Compiling. Let's go to SimArt. See what we get. Okay, that's a bit of a surprise. I asked for A4, and you would think that that would be 40, but I'm getting 50. And that's because the numbering of arrays starts from 0. So this guy is the 0th, the 1st, the 2nd, the 3rd, and the 4th. You have to remember, in C, arrays start at 0 and go up to 1 less than the size of the array. If we want to print out all of our array, we need to use a for loop. This look a little prettier. A percent I percent U. Let's compile this. Go here, clear the page, and now print out. See what we get. Uh-oh. There's a typo here. Ah. Silly me. I meant to say I. Rebuild. Clear the page. And print. Now you can see 0, 1, 2, 3, 4. Great. Now, let's look at this blank variable here. If I want to fill it up with numbers, I need to use a for loop. For instance, let me make each element of B equal to 3 times A plus 2. Semicolon. And down here, we will print B. Okay, seems to work. Let's go to UART. Let's clear the page. And sure enough, that works. So, again, you initialize a one-dimensional array by using curly braces. The elements are numbered from 0. You can't print out an entire array. You can't do something like B equal to A. We don't have any operations that will make one array the same as another array. We have to always use for loops for printing or manipulating them. Here we are with a modified version of the functions program that we just did. Here I want to show you how you pass an array to a function. So here's the prototypes for two functions that I have, and they both involve arrays. And generally what you write down is the array type, and you leave it blank in here, and you tell it the array size. And down here I'm calling the function norm, the name of the array, which is A, you don't need brackets here, and the number of the elements, 5. And what norm does, I'm using the phrase from linear algebra or math, the norm is simply the absolute value of a vector. A 1D array is very much like a 1D vector. So down here we come to norm, and what I do is it takes each value, it squares it, sums them all together, that's what this is doing, and when I'm finished it takes the square root of the sum of the squares and prints it out. Okay. Also, the second thing that I do is with square elements here is that when I pass the array to the function square elements, it actually has that array, and whatever it does to that array happens to the array that you dealt with. Here, when I pass array A, what it's going to do is it's going to take each element and square it. Let's look at the results of this when we run it. Okay. Rebuild. Right. Okay, let's examine this closely. So here's the value for the norm. Okay. It has taken all the values, squared them, and taken the square root. It hasn't changed the value of the functions at all, though. It hasn't changed the elements of the array. So back up here. Okay. In square elements, I actually, where do we go? In square elements, here I am printing out the new values of the arrays, and when I go back into the main part of the program, I print them out again. So you can see that I'm getting that I have in fact changed the values of A. You need to be a little careful about that. You don't want to change you don't want to change array A unless you intend to. So you can pass the array to a function to use its values or to change the values of the array. The style we use in the function is the array should be left blank here, but you should include the array size, how many of the terms that you're going to do this for. When you call the function, you just give it the name of the array, not A bracket 5 bracket. Thanks for now. Now let's move on to bigger arrays, multi-dimensional arrays. In particular, in this example, we're going to look at 2D arrays. Now, the way you would perhaps have encountered matrices before, a matrix is determined in terms of rows times columns. So here's an example of something that looks like a matrix. It has 2 rows with 1, 2, 3, 4 columns. The way you would initialize an array is by giving the values of each row. You could actually leave out those curly braces in here, but it's a good way of doing it. Now, because it's a 2-dimensional array, seeing the elements or working on the elements usually requires nested for loops. What I've done here, here's one for loop for the rows, and a second for loop for the columns. And so I've got 2 rows, so I'm going 0 and 1. And I have 4 rows, 0, 1, 2, 3. And here I'm printing out each element. And each row will be will move down 1. So let's run and see what we get. Let's go back here. Right? File. We got what we want. Print. Pause. Here, let's go back. Okay. As you can see, it worked just the way we want. You can work with higher order arrays if you need, but generally, in most of the problems we'll have in this course, needing something more than a two-dimensional array is pretty unlikely. You can also pass these arrays to functions, very similar to what we did before. And again, but you'd need the size, number of rows, and the number of columns.